All right, good afternoon, grade eights. I hope that you guys are all having a productive Tuesday so far, guys. Um, we're back again for another lesson. Today, this is, I believe, now week 16 or week 17. It's a little bit difficult to keep track, but the point is that we've been making good progress. And I know that I do say this quite a bit, but I think that all of the lessons that we have really do cover some quite important information. And I think it's great that you guys have access to this information, even, beyond the actual lesson that we have. So, grade 8 today, I want to chat about something that's quite important in the world of geometry. I know we've been doing a little bit of jumping around, but I think given that we only have our lessons, once a week, I'm really trying to get through all of the term one work as best I can. Now, I know the last thing we discussed was order of operations last week. So I want us to move on to the theorem of Pythagoras today. And I specifically want us to quickly discuss this because it's something that you are going to be using for quite a while. It's going to usher us into the world of geometry, right? So we want to start with the very basics. I know, like I said, that we have been pretty busy jumping around, but I hope that you guys will be able to bear with me now as we deal with today's work. As per usual, guys, please remember that this is not supposed to be the first time that you are learning any of this. This is supposed to be a supplementary lesson to help aid and sort of patch up some of the misunderstandings that you might have or just gaps in information. All right. So we're going to get going with today's work. I want to just give everyone just 1 or 2 more minutes to quickly join us, but I am going to start by sharing my screen with you. You guys should have all learned the basics of this by now. So me going through it is largely going to be considered revision for your exam, but I hope that there is still going to be 1 or 2 little bits of information that you feel like you can take away from this that you might not have known prior to today's lesson. All right, so you should be able to see my screen now. I'm scribbling in white, yellow, orange, green, and even blue. If for whatever reason during today's lesson you cannot see what I am writing or hear what I'm saying, guys, please let me know and then I will fix that issue as soon as possible. All right. You can let me know by just typing a message into the comment box for me. It doesn't matter whether you're watching on YouTube or on Facebook. So let's get going with today's work. The date is the 13th of May if you want to write that down. And we're going to start talking about the theorem of Pythagoras. Okay. Right. So the theorem of Pythagoras, grade 8s. Let's quickly take a second to zoom out and understand what this is in the context of the rest of the work that we are trying to learn this year, right? This is quite a specific topic. It's quite niche, but it's pretty much one of those topics that belongs to the foundations of geometry. So we know that in geometry, what we are most frequently doing is calculating missing angles and missing lengths, right? Now, the theorem of Pythagoras is a theorem that was established to help us find the length of certain sides of triangles, right? So it applies very specifically to geometry, then it applies very specifically to triangles. And as you see, when we begin writing down a bunch of theory about this, that it actually only applies to right angled triangles very specifically, right? So this is something that we use quite a lot, and it's just another thing that we have to learn that represents an extra way for us to solve something if we're lost, right? It's another tool in our toolbox as far as ideas for solving questions is concerned. So, what I want us to do now is begin by writing down some of the very important information that we need to know about the theorem of Pythagoras. Guys, I am going to move relatively quickly through this. I'm not going to take hours and hours to explain the basics. So, please just bear with me as we do get through some of the more basic information. Okay, first things first. What is the theorem of Pythagoras written down in simple terms, right? In its standard form, we would say that AC squared is equal to AB squared plus BC squared. Now, if you have no idea what that means, that's okay. We're going to talk about it in a second. But what you do need to keep in mind is that this theorem only applies to right-angled triangles, right? It only applies to right-angle triangles. So you might be thinking, okay, so I know what it applies to and I can see sort of what it looks like visually. But what do we have this theorem for in the first place? Right? What is the why around this section of work? Why do we have it? The theorem is used to calculate the length of a missing side of a right-angled triangle, right? It's to calculate the length of a missing side of a right-angled triangle. I would recommend that you guys take notes. You don't have to, it's up to you, but I would recommend doing it. And at the end of today's lesson, guys, I want to show you some of the quizzes that you can use on iRainbow to test yourself on this work and to just practice applying this theorem. Right, so what else do we need to know about this theorem of Pythagoras? So I'm not going to go through all of the specific details in the sense that I will not be showing you how the formula or the theorem was essentially derived, but we do need to discuss something important. Seeing as we're going to be talking about right-angled triangles, it's only fair that we make sure that we thoroughly understand how to label the different elements of the triangle, right? And believe it or not, there are one or two unique names that you might not have known about. So again, I would take notes if you have the opportunity to do so. So looking at a right angled triangle like this over here, we obviously need to have our right angle marking in the 90-degree corner of the triangle. But We can also label our triangle A, B, and C, right? We label it at the corners where our lines meet. Now, when we label this A, B, and C, generally speaking, we are actually supposed to use a little angle marking on the top over here. So it's angle A, angle B, and angle C. Make sure that you are paying attention to the formatting of the letter, right? The fact that it's a capital letter. Sometimes you won't see these angle markings, sometimes you will. It really depends on the situation. So you can choose to write them if you would like to, right? For now, let's just say that this is A, B, and C. Now, let's take a look at corner A, right? If I pay attention to the corner over here, this angle, if I am able to find the side opposite from that angle, we can label it as side A. But the difference is now that it is lowercase. So if this is angle B over here, and we look at the side opposite to angle B, we can call this side B. Again, look at the difference between the upper and lower cases. And finally, looking at angle C sitting over here in the corner, if we find the side opposite to angle C, we are able to find side C, right? Now that's not too complicated. So it's just important to keep in mind, in this case, if I look at side AC, right, traveling from A to C, that is the same as the lowercase b that we've been using. So it does depend on which sort of notation you guys want to use, but it's just important to make sure that you understand this distinction, right? So on the side over here, we can say that side AC is equal to side B, lowercase b. Side AB is equal to small lowercase c. And finally, side BC is equal to side A. Right? Just make sure that you have that information. All the lowercase letters can be used to represent the different sides of a triangle. But generally speaking, as you can see over here in the theorem that we wrote down, it makes reference to the sides, right? So AC, for example, is this long side over here. Side AEB that we see listed second is this side over here. And finally, BC would be the base of my triangle running across the bottom. So what's useful to keep in mind, guys, for the sake of your own studies, especially when you study from varying textbooks and sources, seeing as we know that AC over here is equal to B, right? And we have the same thing for all of the other sides of the triangle. We can actually rewrite this theorem just in different terms. So it's possible that in other textbooks you would see that side B squared is equal to A squared plus C squared. These are two variations of the same theorem, guys. All right. So please just take note of that difference in notation. Neither of them is more correct than the other, and it really just depends on which one your teacher wants to use or which one you prefer using. Okay. Right. Now, there's something else that's quite important to remember. Um, and we're going to write these down sort of as interesting facts over here on the side. We can use a star to just represent important information to remember. This side over here, grade 8 that we see, is opposite the right angle in the triangle, right? Has a unique name, and that name is the hypotenuse. And yes, that is a word that you need to know. So you can say side AC can be called side B, and both of these are still going to be called the hypotenuse. And finally, we must also keep in mind that we have three angles in a triangle, right? And because this is a triangle, angle A plus angle B plus angle C must add up to a grand total always of exactly 180 degrees. Okay, so these are some important bits of information worth remembering. And there's one more thing that you can actually add on here if you want to, grade 8s. The hypotenuse over here, why is it so unique? Why does it have its own name? Well, that's because the hypotenuse is always the longest side of a right angled triangle. So you can write that down as well, because sometimes that can work to your advantage, right? Is always the longest side of a triangle. So, leading us back to the beginning where we started by writing down the theorem in mathematical terms, guys, we can now expand on this a little bit using this diagram that we have over here. So, what are we able to deduce, guys? The theorem in words is something that we are now able to write down because we have a brief understanding of what's going on, right? We know that in mathematical terms, we can say that AC squared is equal to AB squared plus BC squared. But what does this really mean when we write it out in words? Remember, we use the theorem of Pythagoras to help us solve the missing length of one of the sides of a triangle. Right? So, how do we write this theorem into words? The length of the hypotenuse is equal to the square root of the sum of the squared other sides of a triangle. You can write it in a few different ways, guys, but the definition that's given often talks about a square that is found on the edge of your triangle, right? And you can go and look a little bit further into that if you'd like to, but I think that it makes things a little more confusing than necessary. So, again, this doesn't necessarily help us unless we write it out and use it in a few examples. So, there are three variations, and this is very important to remember. We know that the first variation is AC squared is equal to AB squared plus BC squared. Now, let's say that I wasn't actually looking for the hypotenuse of the triangle, right? We know that AC is the hypotenuse over here. How do I know that? If we go up ever so slightly, we know that AC is the longest side of the triangle. And because we normally want to find the hypotenuse with Pythagoras, we keep this as the um, focus of the formula, right? Now, with that being said, we can still create two more variations by changing some of the elements around, by sort of rearranging the theorem. So variation number 2 is that AB squared is equal to AC squared minus BC squared. And finally, BC squared is equal to AC squared minus AB squared. All right. Now, we also spoke about being able to write, for example, the side of a triangle, which could be called AC, also as lowercase b, because it would have been opposite angle B, right? So keeping this in mind, we can also write two more variations or three more variations down, right? Just writing the three rules that we already have in a slightly different format. So we would say B squared is equal to A squared plus C squared. Then we could say C squared is equal to is equal to B squared minus A squared, or finally A squared would be equal to B squared minus C squared. So these are essentially your three variations of the rule written in two possible formats, and they're just helpful to understand. Now, where do these three come from? They help us solve the three different sides of the triangle, right? If we use the hypotenuse as yellow, we then highlight the second side as orange and the third as green. As we move things around over here, you guys will see how the focus of the formula becomes some different value. right? So let me quickly do that. We can see here, once I've highlighted everything, that as we arrange these three formulae, as we rearrange the original theorem, actually, we now have a unique color at the front of each example, right? And these represent the three different sides of the triangle. So let's write one very important piece of information down. This is extremely important. You must have at least two of the three sides you must at least have two of the three sides of a right angled triangle to use the theorem of Pythagoras. Right, to use this theorem, which is Pythag for short. Pythag being short for Pythagoras. Right, I hope that this is making sense. Guys, if you have any questions, please let me know. I'm more than happy to try and explain anything that I haven't explained fully yet. Okay, I'm going to give you guys just a second to copy if you haven't had a chance yet. This is a lot of important information, and the only thing we have left to do is go and look at one or two examples. We're actually going to look at three examples in total today. All right, so I want us to look at three examples, each of which looks at a unique version of the formula that gets used, because it's actually not too bad, guys. Then I'll explain one last interesting fact about this Pythagoras, and we will be done for today. Right. Let's take a look at some examples, guys. I assume you've had more than enough time to copy. If you still do need to ask me to move up so that you can finish copying something, please don't be nervous to ask. I'll do so more than happily. Okay, let's go through some examples where the question is find the length of the missing side. Right, find the length of the missing side. So what I just want to explain to you guys, or not explain, but rather just reiterate, is when we are working with Pythagoras, the law is very simple to remember. Instead of trying to memorize all the letters and stuff like that, which absolutely will confuse you in the long run, you just need to remember that if I take the two shorter sides of a triangle and I square them, it will give me the square of the longest side of the hypotenuse. So let's take a look at this. Let's say this were example number 1. We have our triangle over here, and this is side D, E, or let's say D, E, and F. Okay, and we are told the following. In terms of the sides of these triangles, the longest side is what we want to solve for, so we'll call this F, right? The lowercase version of the angle that it is opposite from. And let's say, for example, we have a side that is 5 units tall and 12 units long, right? We want to find the length of the missing side, grade 8s. So how are we going to do that? Remember, what does Pythagoras tell us in its theorem? The longest side of the triangle, in this case, DE, right? Side DE. You can actually erase the little f if you want to, guys, or you can keep it. It's up to you. But this longest side is going to be equal to the shorter side and the base added together once they've been squared. So we can say the following. DE squared, right? That's our long side over here, is equal to the short side on the left here, the height of the triangle, DF squared, plus this base, which is EF squared. So now we've essentially taken Pythagoras and applied it to our own triangle, right? Applying the letters and the naming conventions in the question that we were given. So here's what we have to work with. Side DE squared is still unknown to us, right? We don't know what the length of this side is, so we'll leave it as is. Now, DF is 5 units long, so we'll square it. And EF is 12 units long, and we'll square it. So, side DE squared is equal to 5 squared is 25, and 12 squared is 144. Right? So when we add all of this together, D squared is 169 units. But we were not asked for the length of DE squared. We just want DE on its own. So what does that tell us we need to do? We've got to square root both sides of this equation. DE squared on the left just becomes DE, and the square root of 169 is 13 units. And so there we go. That's how we solve the most basic version of Pythagoras style questions. So now we know that the longest side of the triangle is 13 units. And does that make sense to us? Well, yes, because it's definitely longer than the 12 centimeters at the base and the 5 centimeters on the left. Okay, so guys, that is how we would go about solving question number 1. And please take careful notes of how I've laid everything out very logically. Okay, let's go on to example number 2. I'm going to draw another triangle while you guys use the opportunity to quickly copy. Remember, Pythagoras only applies to right-angled triangles. They can come in all kinds of funny shapes, but they have to have one right angle at the very minimum and maximum, I guess. Right. Do we have any questions about example number 1, grade 8s? Okay. I haven't seen anything so far. Let's add some information onto our triangle for question number 2. We are told the following. Right. Let's take a look at example number 2. We have triangle QRS that we are busy working in. Right? We've been given certain amounts of information which tell us that the longest side of the triangle has 25 units worth of length. The base of the triangle has 24 units, but we are left wondering what the value of the remaining side is. Okay, so that's what we want to solve. Now, please pay attention to this very carefully. We know that this longest side over here is the hypotenuse because it is opposite our right angle. So it is not even a question that side QR is our hypotenuse. So let's quickly write out Pythag, or the theorem of Pythagoras, in full using this, and then we can rearrange it. So we know that the longest side of the triangle is side QR. So QR squared has got to be equal to both of these other sides, which are squared, added together. So we need QS, which is on the left over here, right? So we can say it's QS squared plus the remaining side RS squared. So this is the theorem of Pythagoras in the context of this triangle. Now, what are we solving for? What are we looking to be the focus of our equation? Guys, we are looking for the length of this side over here, right? Side QS. QS. So, what we can always go and do is highlight this in our formula because this is what we want to have on its own. So, in order to have QS on its own, we're going to have to take RS over to the other side, right? And when we take something over the equal sign, we know that it must change its sign. So, on the left, we are going to have QR squared minus RS squared. And that's going to be equal to our focal point QS squared. Now, in this sort of situation in an equation, you're allowed to switch the two sides around, so we can rewrite it as QS squared, right? We move the right-hand side to the left, and we keep whatever was on the left-hand side in exactly the same order, but on the right-hand side. Okay. So now we know how we are going to solve for this missing side QS. We have adjusted our formula, right, accordingly. So let's go ahead and apply it. We know that QS squared is equal to QR squared minus RS squared. So QS is the side that we are solving for, so we'll leave that as is. QR has a length of 25 units squared, and RS is 24 units squared. Do not forget the square symbol, please, guys. So you can go and put this straight into your calculator, but for those of you that don't have a calculator with you, I'll write this out in an extra step. 25 squared is the same as 625, while 24 squared is the same as 576. If I do the maths and I subtract these two from one another, we find that QS squared has a value of 47. To get QS on its own, we need to square root both sides of the equation. Sorry, guys, I said 49 and I wrote 47 here. QS squared is 49. So what is the square root of 49, guys? It's going to be 7. Now, does this make sense looking at our triangle? Is it possible that the missing side can be just 7 units in length? Absolutely, it could be. And guys, if you're not 100% sure, go and write 7 onto the diagram over here and complete the very first step of Pythagoras. If you get the right answer for the hypotenuse, then it means that you've done Pythagoras correctly. Okay. So this is what you would get marks for over here. But I do think that it's very useful to understand where the variation of the formula has come from. All right. I'll give you guys an opportunity to copy very quickly. I just want to move all of this side by side. I apologize for stuff shifting around. Okay. We'll do one last triangle solving for the third and final unknown side, and then we will be done for today. But I obviously will show you guys some exercises that you can use um, practice this. All right. It's not extremely difficult, but like I said, guys, you need to remember that the theorem of Pythagoras is essentially just an extra tool that you have in your arsenal to help you solve geometry questions. So while it's often not tested in a very obvious fashion, it does get tested often in word problems and geometry questions, like I said. All right. If you guys have any questions, please make sure that you ask. I'm more than happy to answer any questions that you guys might have. Let's go on to the very last example for the day, guys. I'm going to try and leave the calculations on the screen while I draw triangle number 3. Remember, Pythagoras only works with right-angled triangles. I know I sound repetitive, but that's the point. Okay, a right-angled triangle. Example number 3, the last one we're going to do today, a variation of finding the third and final missing side. Let's say we are working with triangle JKL. We know the measurements of 2 of the sides. The first one is going to be, let's see quickly. Let's go 17 units on the hypotenuse, right? And 8 units along the shorter side of my triangle. Right, that means that the final missing side is this base of our triangle over here. So once again, we need to start this question off by applying the concept of Pythagoras to this specific example. Okay, so we want to use the naming conventions from this specific triangle. So we know that the longest side in this case, JK, the hypotenuse, right? We know that's the hypotenuse because it is opposite our square angle, our right angle. We know that that side is the sum of our 2 shorter sides of the triangles. So let's start with that. We know that side JK squared, our hypotenuse, is JL squared plus KL squared. Right? Now, what side are we looking for? We're looking for the side across the bottom here, the base, KL or LK. Doesn't matter which way you prefer to write it. We usually just like writing things in alphabetical order. So if I want KL squared on its own, it means that I would need to move JL squared over to the left-hand side. So when I move something over, it changes sign. So it's now a minus sign, leaving me with KL squared on its own on the right-hand side. We can flip this around just so that it reads a little bit more nicely. And there we go. We now have the formula that we want to use to find the length of the missing side. So let's apply it. KL squared is equal to JK squared minus JL squared. So we are looking for KL. JK has a length of 17 units and JL has a length of 8 units. Again, guys, you can go ahead and put this into your calculator. I'm going to write down the values just so that anyone that doesn't have a calculator is able to understand where these numbers are coming from. Right, so when we do all of this, we get to an answer of 225. Now, keep in mind, this is still for KL squared. We don't want the squared version of the answer. So, in order to counteract the square symbol, we square root. But what we do to one side of the equation, we must also do to the other. On the left, the square symbol and the square root symbol will cancel one another. And so we find ourselves looking for the square root of 225, which is a value of 15 units. And again, is it possible that this long base is 15 units? Yes, because it's definitely longer than the height, which is only 8, but it must be shorter than the hypotenuse, right? The longest side of my triangle, always. Right, so there we go, guys. You've now been through an example using Pythag, or the theorem of Pythagoras in full, that shows you how to calculate the length of any missing side on the triangle. And I think it's actually quite easy to do, guys. Yes, it is fundamental. Yes, it's important, because if you try and, go into a test and all of your options for solving these questions are faulty, it's no surprise that you're going to have a bit of a tough time. Okay, so we need to make sure that we practice Pythag. It shouldn't take you more than 1 or 2 afternoons of consistent practice. It's one of those things that sort of, once you're familiar with it, you don't really forget it. Okay. So, grade 8s, I'll give you 1 more minute to quickly finish copying, and then I'm going to move on to show you guys iRainbow. We only have 5 minutes left. Okay. Guys, if you need me to come back to this in a minute or 2 so that you can finish copying, you're going to have to please let me know. But for now, I want to quickly hop over to iRainbow to quickly show you guys what you can use to practice this section of work, right? It's not anything too crazy, but I do want to just make sure that you know of it so that you can use it whenever you feel that you need to. Right. So grade 8s, If you guys are looking to practice this section of work, which I would just recommend you do for a little bit, guys, you need to go across onto your mathematics section on iRainbow. Once you are here, you can then click, sorry guys, on our first topic here, patterns, functions, and algebra. Okay, once you have done this, you can then click on, I believe, sorry guys, just give me a second. It looks like I lost the quiz as well. Sorry guys, go back right to the beginning. We want to click on the topic of measurement first. Okay, you need to click on measurement. Once you've clicked on measurement, you can then click on the theorem of Pythagoras, and under here you will find 4 different quizzes that you can use to practice this. Okay, it will help you practice identifying the names of the sides of the triangles, calculating missing values, and just applying Pythagoras in general to specific questions. All right, so just as an example, guys, if I click on the theorem of Pythagoras at the top left, the very first option, you'll see that I'm greeted with a PDF that helps to explain many of the basics that we've chatted about today. If you want, you can go ahead and take a look through it. And it doesn't matter which one you dive into, you'll see that there is going to be a PDF to greet you, to just explain some of the basics, and then you can go straight onto the questions and attempt solving some of them on your own. All right. So guys, I really hope that you'll use this. Remember, you can go and look at the reports over here, this tab on the left hand side, to go and look at the marks that you got for those quizzes that you tried. These are obviously not relevant for now, but they will be when they pop up on your screen. Okay, so grade 8s, guys, that really is going to be it for today as far as our lesson is concerned. I hope that there was something for you guys to take away from this, some value that you derived from today's lesson. Please keep in mind our next lesson is going to be next week, Tuesday, again from 4:15 to 5:15 in the afternoon. Okay, so I hope that I'll see you guys then. But until then, grade 8s, I hope you have a great week ahead, guys, and I'll chat to you all then. All right, thank you so much, guys.